And then just very recently, a new technique has started to transform the agricultural industry in the entire world. It's called marker-assisted selection. And I'm going to explain what that is, but it has to do with the fact that now we know how genes work. But just about the same time that people started to figure out how genes work and how to use that information to guide breeding, they took what was really kind of a wrong turn for a little while. And they started doing genetic modification of plants, which is where you're just taking other genes and sticking them in there, and you're not really driving evolution anymore, you're just altering the plant by putting in a foreign gene. But at this point, marker-assisted breeding is actually starting to kind of win the day over genetic modification. It's a technique that leverages the best science we have to help traditional breeders do traditional breeding. It doesn't involve introducing foreign genes at all. And even big companies like Monsanto and Syngenta and Dow Agro are doing marker-assisted selection now. In the last few years, a bunch of commercial plant varieties have been released that were made with marker-assisted selection. This is just a little example of a few of them. And this is a little pamphlet that Greenpeace put out, just sort of touting the virtues of marker-assisted selection, because it really is a biotechnology for plant breeding that does not involve genetic engineering, but it has the potential to solve the world's hunger problems because it can create new plant varieties just as quickly and powerfully as genetic engineering can, but in a way that creates a whole real plant that doesn't have foreign genes introduced into it. So here's what it is. For years, people just did classical breeding where they picked plants and they would cross them and then look at all the progeny and pick the ones they wanted. Here's how it worked. This is the old version. You take pollen from a male plant. This is an electron micrograph of one single grain of cannabis pollen. That's actually cannabis pollen right there. You collect some from the male that you want. You paint it on the female that you want, very carefully. The female makes seeds, collect the seeds, plant the seeds, and then you have to grow all the plants up to maturity, and then you have to smoke them and see how you like them, and then you pick the ones you like the best, and then you repeat, right? So that's classical breeding. This is how marker-assisted breeding works. It's pretty similar. You start with pollen, you make a cross, you collect the seeds, you plant the seedlings, but now you plant the seedlings a little differently, right? You do tens of thousands of seedlings under LED lights. This is actually an indoor basil farm, which is super cool. But this is how you grow seedlings when you're doing marker-assisted selection. And then you take the DNA out of all of those seedlings. You just take a tiny little snip out of every leaf. You take the DNA and you put it on one of these sequencers that have just recently been invented that can sequence a human genome in a couple days. And you read the DNA. And if you know what genes are associated with which traits, when you read the DNA, you know which of your seedlings have the traits you want. So you don't need to grow them up and smoke them. You will eventually get to grow them up and smoke them, but you don't have to do that every generation. Because you know which seedlings have powdery mildew resistance and which seedlings are going to be high THC or high yielders or smell like chocolate and oranges. You know that because you know what the genes are. And then you do the next cross.